So the goal, of course, of today's experiment will be to determine, right, the acid content, of course, in a vitamin C tablet. And so I should note, right, that your vitamin C contains, of course, the weak acid, ascorbic acid. And in today's lab, I'm actually starting off, of course, with a tablet, right, that can actually, so this is the actual amount, that actually contains 500 milligrams of ascorbic acid. And the goal, hopefully, is to see if you can determine, right, based, of course, on an experiment, what, of course, is the mass of ascorbic acid in, of course, each of your tablets. So we're going to be repeating this experiment. So we're going to do this twice. In each time, of course, right, please recognize that I'm starting off, of course, with one tablet. And that tablet, you know, theoretically, right, contains what? 500 milligrams of course, ascorbic acid. So how are we going to proceed? So this experiment is going to be very similar to the experiment that we completed last week, right? It's going to actually just be a titration, of course, lab. However, in today's experiment, we're starting off, of course, with a known solution of NaOH. So the molarity, this is the solution that we prepared earlier. The molarity, of course, of our sodium hydroxide solution is known. And so how can we use this information to actually determine, right, the mass of ascorbic acid in our tablet? And so just as always, right, you should recall that everything is truly based, right, on a balanced chemical equation. If, of course, I know the moles of sodium hydroxide, so if the moles, of course, of sodium hydroxide can be determined, because, of course, this is a 1-to-1, of course, ratio, then the moles of sodium hydroxide will be exactly equal to what my moles of ascorbic acid. And, of course, if I know the moles of ascorbic acid, hopefully from your calculations, we can convert this to what? To the grams, right, of ascorbic acid. Of course, my goal is for you to determine that mass in milligrams, but I know that we can all convert, right, to grams, of course, with ascorbic acid to the milligram of ascorbic acid. So as I noted, right, this will be done by means of what? A titration. So just as before, our sodium hydroxide solution will be placed, of course, in our burette. Please note the molarity of that sodium hydroxide is known, right? In our, of course, our Erlenmeyer flask, I have crushed, so we have crushed, of course, our tablet, and of course, I know the exact mass, of course, right, of that, of course, tablet. Now, please note, that mass will be greater than 500 milligrams, and the reason for that, of course, right, there are binders, right, that are used, of course, to actually make, of course, right, each tablet. However, at the end, you should be able to determine the mass of that acid. So what are we going to do? Well, just by means of an experiment, you will again record, well, the initial volume of sodium hydroxide in your container. And again, I'm going to fill that to about, well, to the 0 mark. Again, it reads to 2 decimal, of course, places. At the end, of course, of this titration, you will know what? The final volume of NaOH. And so just by differences, you will know the exact volume of sodium hydroxide, right, that was used. Please note, if you know the volume of sodium hydroxide, the molarity is known, it's 0.0987, you should therefore be able to calculate the, of course, what? You should be able to calculate the moles, right, of your sodium hydroxide solution. Using your equation, molarity is equal to moles over volume. If you rearrange that equation, right, then we can determine the number of moles, because moles is molarity times volume. But do not forget that that volume has to be in liters. Once the moles of sodium hydroxide, of course, is known, then you'll also, right, be able to predict the moles, of course, of ascorbic acid. And then later convert that to grams. Now, care again must be taken, right? This is a titration experiment. So we want to make sure that we're not over-titrating. So the solution at the end, at that end point, the solution again should be, of course, what? Faint pink. Just as a reminder, When you're using that burette, do not forget that the tip of the burette must also be filled, completely filled, and be void of any air bubble. So in this experiment, we're starting off, of course, with our vitamin C tablets. And please note that using, of course, a mortar and pestle, I actually crushed that tablet, and so and then was transferred right to an Erlenmeyer flask. So please, using of course your pads, you want to make sure you record this information. So the mass of my empty Erlenmeyer flask was 141.028 grams. And then when I added the tablets, right, that mass, of course, the new mass is 141.687 grams. That's actually, of course, for our first, right, tablet. Now, the next step, of course, will be, it's going to be impossible for us to do this titration with a solid. So we're going to take a few minutes to dissolve, of course, the tablets in 75 mLs of water. Now, I also need for you to note, there's a good chance, you should expect that not all the solid will, of course, dissolve. And what's the reason for that? But a lot of our binders, right, believe it or not, contain more complex, of course, organic molecules, for example, starch. And so starch, of course, is not soluble in water. So I'm going to, however, stir for a few minutes to get as much of, at least to get all, not as much, to get all the vitamin C in solution, but noting at the same time, of course, that there will be undissolved solid. And as before, do not forget that in order to determine when this, of course, neutralization is complete, right, we will need, of course, our indicator. So I've added, of course, 2 to 3 drops of phenolphthalein. So that's, again, the same indicator that we used, of course, earlier this semester. So now that, of course, my vitamin C tablet has dissolved, right? Take care and look at that solution. It is a little cloudy, again, due to the fact that we have these of course, binders that are insoluble in water. My burette, of course, is now reading 0.0 milliliters. And again, drop-wise, as slowly as possible, I'm going to be, of course, add in, of course, my base NaOH to this solution. But with the aid, of course, of my water bottle, distilled water, I'm going to be, of course, rinsing the inner walls of my container. Again, making sure that I do not add more rather than the required amount. And we will know when this titration is complete. I'm using the same indicator, right? So the neutralization will be complete when this solution, of course, turns faint pink. Notice as we near, of course, that end point, right? We want to make sure that we're adding, of course, our base slowly. Alright, so I know that this is going to take approximately, and you can actually, believe it or not, calculate backwards. I know it's going to take approximately 20-something mLs. So now that I'm at about 20 mLs, I'm going to make sure that I do this slowly. Okay. So this is before, right? Using, of course, my wash bottle. I'm going to take a minute to wash the inner walls of my container in case there's any sodium hydroxide solution adhering to the walls. Oh, perfect. So now that the solution is faint pink in color, right, let's go back and check and see exactly what volume of sodium hydroxide was used. So we started off, don't forget, initially with 0.00 milliliters, and now that volume, of course, is at 29.40 mLs. And so we used, of course, 29.40 milliliters of sodium hydroxide in the first titration. I'm going to repeat the same, right, for my second tablet, so that, of course, you can, of course, record an average later. So we're going to be moving on to our second titration. So again, please make a note, of course, of the mass of our materials. So the mass of our empty Erlenmeyer flask in part 2 is 114.665 grams. Again, 114.665 grams. We crushed that vitamin C tablet, and the container with the vitamin C tablet is 115.322 grams. Again, 115.322 grams. And so we're going to dissolve, of course, our vitamin C tablet. Again, of course, in 75 milliliters of water. Once it's dissolved completely, I will then go ahead, of course, and add, right, my 2 to 3 drops of that indicator phenolphthalein. Again, I can assure you that the solid will not completely dissolve. All right. And so again, I'm going to slowly add sodium hydroxide to my my flask. But please keep in mind that this time around, I know that I'm going to need, right, approximately 20-something milliliters. And so I can first add down to about maybe 20, 22 mLs, and then I will gradually add after. Okay, I'm going to pause again and just, of course, wash the inner walls of my container with, of course, some distilled water. This again will not affect the number of moles, right, of either the acid or the base. Now, care has to be taken for the next 1 or 2 mLs to make sure that I do not add too much sodium hydroxide. I think that looks perfect. Alrighty. So that solution is fairly faint pink. And that's as best as we're going to get a faint pink color today. Alright, so let's see exactly what volume was used this time around. And so here the volume is 28.20 milliliters.